In this lesson, we're going to use square roots to solve quadratic equations. Example 1, how do I solve quadratic equations with a square root? First of all, we know that it's a quadratic equation when we have an x squared, and we should expect to get two solutions. All right, for number 1, then we have x squared is equal to d, and d is going to be greater than 0. And so we're going to solve this then by isolating the variable. And to undo an x squared, the opposite of x squared is to take its square root. So to get down to just the 1x, we're going to take the square root. And if we take the square root or place down the square root sign, we do have to put a plus or a minus before it. So then that means that we're going to have a positive and a negative 7 for our solution. Now, in this case then, this one right here, this has two solutions. And the two solutions are the positive 7 and the negative 7. In the next case, we have d is equal to 0. And so in this case, we're going to come and we're going to undo the x squared and then have plus or minus. So we'll have is equal to plus or minus 0. But in reality, there's really only going to be one 0. X is just going to be equal to 0. You would never say that we've got a positive 0 and a negative 0. So in this case, we have one solution. And then in number 3, we've got x squared is equal to d, and d is going to be less than 0. In this case, then, we're going to come and we're going to take the square root, and then we could come take plus or minus. Well, we cannot take the square root of a negative number. We cannot take the square root of that. You can't do that. And so this is going to be then a no solution. And you'd find that if you try to plug the square root of negative 6 or any number into the calculator, you're going to end up getting an error. All right, so let's go ahead and solve the equation. 14x squared minus 42 is equal to 1092. So we're going to solve this as a fence problem. We're going to isolate the variable here, and I'm going to then start by adding the 42. And we have 14x squared is equal to then 1134. And just like when we're solving when we just have the 1x, we need to isolate the variable. So we're going to then divide by 14. And so x squared is going to be equal to 81. All right, so now we have to continue here, and we have to then undo the square root by, undo the square by taking the square root, and that will result in an x. And so we're going to have then a plus or a minus 9. So the solution to this is a positive 9 and a negative 9. All right, question number 2, we have 25w squared plus 8 is equal to 24. Well, again, we're going to isolate the variable here. So we're going to start by subtracting the 8. And we'll have 16. And you have 25w squared. All right. So now that 25 is multiplying, so we're going to divide by 25 on both sides. And I would leave these as a fraction. I think it's going to be a lot easier that way than to make them into a decimal. So now you've got w squared is equal to 16 all over 25. All right, so now we need to isolate and get down to just the 1w. So if I take the square root of w squared, that gives me w. And then I'm going to take the square root of my 16 all over 25. And notice you can take the square root of 16, and that's 4. So you're going to have a plus or minus here. You're going to have a 4. And then you could take the square root of 25, and that's going to be 5. So your answer here is w is equal to plus or minus 4/5. All right, so for question number 3, we have 5w squared plus 12 is equal to negative 8. So again, we're going to isolate our variable. We're going to start by subtracting the 12. And we have 5w squared is equal to negative 20. And then we're going to divide by 5. Now we have w squared is equal to negative 4. Now notice that we have a w squared is equal to a negative 4. And if I went to go take the square root of that negative 4, it's going to end up being a no solution. All right, for question number 4, we have 2x squared plus 11 is equal to 11. All right, so again, we're going to isolate the variable by minusing the 11. And anytime you divide, or 0 divided by any number, it's going to give you 0. And in this case, we're going to take the square root, but we're just going to have the one solution. X is going to just be equal to 0. All right, for question number 5, let's go ahead and we're going to solve again. We're going to minus 20. I have 5x squared that is equal to 14. I'm going to divide by 5. Now I've got x squared is equal to 14 all over 5. Now in this case, since you can't, you could either just leave this as that fraction, or I would even in this case, because you can't take the square root of 14 and the square root of 5, I would turn that to a decimal. So I have x squared is equal to 2.8. And so then I would go ahead and let's take the square root of. So x is going to be equal to then plus or minus 0.67. All right, example number 2. How do I solve a multi-step problem? All right, so we have this following object. It says a remote control blimp drops t-shirts at the Timberwolves games. If the blimp is flying at a height of 55 feet and the spectator who catches the t-shirt is at a height of 17 feet, how long will it take the t-shirt to be in the air? All right, so we're going to use the vertical velocity formula, and I'm going to write down the formula and then I'll tell you what each part means. H is equal to negative 16 t squared plus vt plus s. All right, so the negative 16 represents the gravity that's pulling at the object. The t represents the time. The v is going to represent the vertical velocity, or the initial velocity. The s is our starting height. And then the h represents our ending height. So now let's go ahead and plug in what we know. So the blimp is flying at a height of 55. So that's our starting height. So we'll have 55 right here. And then we've got our negative 16. And it says how long. So what we're looking for then, how long will the t-shirts be in the air? So we don't know the time. So we have t squared. And we do have then the ending height, which is going to be 17 feet. All right, now one thing we don't have here is the vertical velocity, or the initial velocity. Because the balloon is flying at the height of 55 and then just dropping it instead of launching something, we're not going to have then, in this case, we don't have the initial velocity. So let's go ahead and we're going to then solve this equation and we can find out how much time. All right, so let's start by isolating the variables. So we're going to subtract the 55. And we get negative 38 divide by our negative 16. So we're going to have t squared is equal to 2.375. All right, so now we're going to take the square root. So now let's think about this. We're talking about time, and we could never just have a negative amount of time. And so the only answer that we can have then is our positive answer. The other answer ends up being what we call an extraneous solution. It's just one that wouldn't make sense. So t then is going to be equal to 1.54 seconds. All right, for our last example here, it says if an exchange student drops her camera off the top of the Eiffel Tower from a height of 1,063 feet, how long will it take to hit the ground? So again, so we've got the starting height is going to be 1063, and then we have our negative 16 t squared. Now, as far as our vertical or our initial velocity, again, we're just dropping it from that height of 1063. So because we're dropping it from there, that's going to be 0. So that will cancel out. And then as far as we have our ending height, and since it's dropping to the ground, is going to be 0. So let's go ahead, we'll isolate the variable. We're going to subtract the 1063. And then we're going to divide by the negative 16. And so we'll have our t squared then is equal to 66.4. So now again, we're going to take the square root, but because we're taking the square root then and we're looking for the time, we can't have a negative answer. So we're just going to have the positive answer, and that the time is going to be 8.2 seconds. All right, so in this lesson, we took a look at how to solve quadratic equations by finding the square root.